Hello. Let's assume a customs office uses a machine and lets 70% of the people through and 30% of the people get searched. If we pick 50 people to go through the line, use some random numbers to figure out how many people go through. Now we could do this with our calculator, where we let numbers 1 through 7 go through and 8 through 10 get checked. And if we pick 50 numbers, what we do is we'd do a random integer of 50 numbers, and then we check what percent go through. Now, if we know 70% are going to go through, we know sometimes it might be down to 68. Sometimes it might be up to 73. But we want to get a distribution of everybody, of many, many samples. So to save us some time and effort, we have a distribution here. As you can see, most of the time, 70 or the not most of the time, but 70 the largest value is at 70%. That's what we would expect. But sometimes it's a little bit more and a little bit less. And here they did this simulation 1,000 times. Now, if it happened where it was 85% or 90%, you'd see that that is going to be really rare if the sampling proportion is really 0.7 of the population is. So that is what we call a sampling distribution. So that is the sampling distribution of a statistic is the distribution of the values taken by the statistic in all the possible samples of the same size from the same population. So it creates this big distribution of everything that's possible. Now let's create a sampling distribution. So we want to do a distribution of numbers between 0 through 9. And let's do 50 numbers. So what I did is I took my calculator out and I did 50 random numbers and put them in L1 using random integer. So if I looked at this, if I go to L1, let's try that again. And I did zoom 9. That would be a pretty reasonable graph. But there's not 10 things here, so what we need to do is look at the window and go from 0 to say, or let's go to 10, give us some wiggle room, and let's go up by 1 each time. Now when we have this graph, you can see that what it looks like. Now, if I wanted to describe this distribution, we talk about the shape. It doesn't look it's kind of symmetric, but the main way to describe this shape would be uniform. It's pretty straight across the probability. Sometimes it's a little up, sometimes a little down, but I would call this a uniform distribution. The center of the distribution is going to be somewhere in the middle. I would guess that to be 4 or 5. And the spread of the distribution, we could do standard deviation or variance. But in this case, let's do range, because it's 9 minus 0, which is 9. And there's no outliers in this situation. So this is just one set of numbers. Now let's say we picked 2 random numbers and found the mean between them and did that 50 times. Let's look at that distribution of the data. So what I did is I put this data in L1 and I did another list in L2 and I found the average of them by adding L1 plus L2 and divided by 2. When I do this, if I look at the stat plot of this one, now I have this in L3. If I graph it, there's much more because it's possible to be 0.5s. So maybe instead of going by 1s, I'll want to go up by 0.5. Now this will be a better distribution. So it looks something like this. So now hopefully you see that it's not as uniform and it kind of goes up and down again. So if I want to describe the shape, I would say it's somewhat symmetric. The center is still around 4.55. The spread, now it still goes from 0 to 9, so I would say the range is 9 still, and still we don't have any outliers. Now if we did this 200 times, now it's going to get even more rounded like that, and it will look something like this. This is the theoretical. So if you wanted to find out all the different possibilities, this is what it would look like. So your samples will get closer and closer to that distribution.